Two steel rails disappear into a tunnel beneath downtown Chicago, but they are far too close together for any train most people would recognize. Beside them sits a tiny electric freight locomotive, squeezed into a passage so confined that the machine itself becomes the scale. I kept looking at those rails because they change what this tunnel is. This was not simply a utility corridor or an abandoned basement passage. The track was approximately 2 feet wide. Something had been deliberately engineered to move through here, and whatever it carried had to fit inside this narrow underground world. The explanation is documented. Beginning around 1900, tunnels beneath Chicago were constructed large enough for a narrow-gauge electric railway. Freight service began in 1906, moving packages, commercial goods, coal, and ash beneath crowded downtown streets. But the smallness of the railway hides the scale of the decision, because this cramped passage was not an isolated industrial tunnel. Within only a few years, it belonged to a network stretching roughly 60 miles beneath downtown Chicago, and that is where the story becomes stranger. The railway eventually lost its purpose. Operations ended in 1959. The locomotives stopped moving. The freight disappeared, but the infrastructure did not disappear with them. More than 3 decades later, Chicago would discover just how much of an obsolete transportation system could remain physically embedded beneath a modern city. The clearest proof appeared beneath the Chicago River, beside the Kinzie Street Bridge. There, one section of the old freight system passed beneath the river. By 1992, that tunnel had not carried commercial trains for more than 30 years, yet its concrete structure was still there, and more importantly, it was still connected to other surviving sections beneath the loop. That connection turned a small area of damage into something much larger. Illinois Supreme Court records later reconstructed what happened. In 1991, the city of Chicago had contracted for work involving protective pilings around several river bridges, including the bridge at Kinzie Street. The project documents specifically warned that even relatively small changes in piling position could threaten underground structures. At Kinzie, pilings were installed in a position different from the one originally specified. The resulting pile-driving work damaged the old freight tunnel. The legal findings describe the effect carefully. The work broke, weakened, or placed excessive pressure on the tunnel structure. That distinction matters. The evidence does not require the dramatic image of a piling punching cleanly through the roof. What matters is that the old tunnel was physically compromised, and the damage did not remain completely hidden. In January 1992, a television crew using the tunnel encountered the affected area. By February, the city had been notified. Municipal personnel later inspected and photographed the damage, and recommendations for immediate repair followed during March and early April. So, this is not a story in which Chicago suddenly discovered that an unknown tunnel existed beneath the river. The more difficult fact is almost the opposite. The tunnel was known, the damage was known, and the structure still mattered enough that on April 13, 1992, when the breach opened and river water entered the old system, an obsolete railway began behaving like a functioning network again. To understand why, the most useful evidence is not the breach itself. It is a map. A surviving map of the freight system from around 1930 shows lines spreading beneath the central business district, following street after street and branching toward buildings and freight facilities. The network looks less like a single subway line than a circulatory system beneath downtown Chicago. That changes the scale of the Kinzie Street failure. A hole beneath the river was one problem. A hole connected to roughly 60 miles of underground infrastructure was another, and the map reveals something else. These tunnels had not been constructed merely to pass beneath downtown. They were designed to enter the working life of downtown buildings. That was the entire advantage. At the beginning of the 20th century, Chicago's streets were already carrying the burden of an enormous commercial city. Railroads brought freight into central terminals. Businesses required deliveries. Boilers required coal. Those boilers produced ash that had to leave again. Packages and merchandise had to move through streets already crowded with traffic. The tunnel railway offered a different route. Freight, arriving at conventional railroad facilities, could be transferred into the narrow underground system. Small electric locomotives could then carry it beneath the streets toward individual customers. Coal could move toward basement boiler facilities. Ash could travel outward. Merchandise and packages could reach commercial buildings without making the entire journey through surface congestion. The railway was therefore small because the world it served was constrained. Its 2-foot gauge track was not an eccentric miniature version of a normal railroad. It was an engineering response to an entirely different operating environment. And once that environment is visible, one surviving photograph becomes much more important. University of Chicago collections preserve an image identified as the tunnel entrance to Marshall Fields. The significance is not the department store itself, it is the entrance. The photograph demonstrates that the railway did not remain safely separated beneath the public streets. It connected directly with one of downtown Chicago's major commercial buildings. That physical relationship was essential when the railway worked. Decades later, it would become the reason an abandoned transportation system could still affect basements above it. But even during construction, Chicago already had evidence that what happened inside these tunnels could affect the city outside them. In 1905, the Chicago Department of Public Works appointed an engineering commission to investigate the Illinois Tunnel Company system. Its report survives. Among the issues examined was surface settlement connected with tunnel construction, including settlement around State Street and Jackson Boulevard associated with underground turnout curves. That record matters for a reason larger than the engineering problem it describes. It shows that the freight tunnels were never simply a secret world operating beneath an unaware city government. Municipal engineers were studying them while the network was still being built. The city above and the system below were physically related from the beginning. The tunnel builders themselves left another kind of evidence. Company publications survive with maps, operational photographs, statistics, and descriptions of the system. One presented the Chicago subway system constructed by the Illinois Tunnel Company. Another, from around 1928, was titled The Chicago Freight Tunnels. These documents were promotional material, so they have to be read as company publications rather than neutral historical analysis. But they still reveal what the operators wanted people to understand. This was infrastructure. It was a commercial system intended to make downtown work differently, and by then, the scale was extraordinary. Freight service had begun in 1906. By 1909, roughly 60 miles of tunnels had largely been completed beneath the central business district. Historical estimates are not perfectly uniform. During the 1992 emergency, a U.S. Army Corps of Engineers account referred to more than 70 miles of tunnel. Chicago historical sources more commonly described the system as roughly 60 miles. Whatever boundary different records were counting, the essential fact does not change. The network was vast enough to connect much of downtown beneath the streets. Its construction history, however, contains one genuine uncertainty. The earliest underground work grew from authority granted in 1899 to an independent telephone concern for installing telephone cables beneath downtown streets. Construction began around 1900. What is less certain is exactly when freight transportation became part of the plan. University of Chicago historical material specifically cautions against assuming that the railway had secretly been the intention from the first moment. The evidence supports the tunnels becoming large enough for railway operation. It does not fully settle whether freight transportation was always the concealed original purpose or emerged as the project developed. That uncertainty is useful because it prevents the system from becoming more mysterious than the documentation allows. Its engineering is remarkable enough without inventing another history for it. Chief engineer and contractor George W. Jackson was closely associated with the tunnel work, and a 1910 United States patent preserves technical drawings connected with his subway construction methods. Those drawings reduce the underground network to geometry, structural method, and engineering problem-solving. They also remind us what these tunnels actually were. They were not designed as grand civic spaces. They were working passages. Contemporary photographs show locomotives and cars confined inside them, their scale determined by the narrow underground route. There was no passenger concourse, no monumental station, no hidden residential district. Calling this an underground city is useful only as a description of scale and connectivity. Historically, it was a freight railway, and for several decades, it had a clear reason to exist. Then, the city around it began changing. Motor trucks became increasingly capable competitors for urban freight. Passenger subway construction, beginning in the late 1930s, cut through or displaced important portions of the freight network. Downtown heating systems also changed, reducing the coal traffic that had once provided the Underground Railway with one of its most natural cargoes. The system's economic purpose weakened. In July 1959, freight operations ended, and this is the moment where the history of the railway divides into two completely different stories. The first story ends cleanly. The trains stop. The commercial service disappears. The railway is abandoned. The second story does not end, because abandonment described the function of the system. It did not describe the physical condition of every tunnel beneath Chicago. Most of the tunnels remained in place. Some sections later carried utilities and communications infrastructure. Illinois Supreme Court records state that after 1959 the city owned the tunnel system and, beginning in the 1970s, leased space within it to utility and telecommunications companies. That fact changes what the word abandoned means. By then, the railway was dead as a railway, but portions of the underground structure had already acquired a second life, and the network still retained one of the features that had made it commercially valuable in the first place: connections. The Illinois Supreme Court later described many loop buildings as directly or indirectly connected to the old tunnels. Those openings and interfaces were remnants of the freight system's original logic. A railway designed to deliver directly into downtown buildings was useful, precisely because it did not remain isolated from them. After the trains disappeared, the geometry remained, and that is the geometry we have to keep in mind when returning to the tunnel beneath Kinzie Street. The damaged section did not sit at the end of an unused passage. It belonged to a network whose original purpose had been to connect things. On April 13, 1992, the Chicago River found that network. Water entered through the breach and moved into the old freight tunnels. From there, the surviving system provided a route through the central business district. Buildings with open tunnel connections became vulnerable from below. University of Chicago historical material identifies approximately 24 downtown buildings affected through those connections. The disaster, therefore, cannot be understood simply by imagining water leaking through one damaged tunnel wall. The breach explains how the river got in. The map explains what happened next. The old railway distributed the consequences. A feature designed decades earlier to move freight efficiently from one part of downtown to another was now allowing river water to travel through the same underground geography. The system's commercial strength had become an infrastructure weakness, and the emergency response reveals just how seriously that surviving network had to be treated. The U.S. Army Corps of Engineers became involved in locating and isolating the leak, monitoring tunnel water, determining pumping requirements, and helping create barriers. Contemporary federal documentation described an emergency taking place roughly 30 to 50 feet beneath downtown streets. Engineers sank large shafts near the river crossing. Rock and sandbags were used in blockage efforts. Underwater grouting helped establish plugs. Permanent concrete bulkheads were installed. Additional isolation measures were planned at other places where the freight tunnels crossed beneath the river. The objective was no longer to make the network operate. It was to stop it from operating as a network. That is the reversal at the center of the entire history. Around the beginning of the 20th century, engineers had invested enormous effort in creating underground continuity beneath Chicago. In 1992, engineers had to regain control by breaking that continuity into manageable sections. And once that is visible, the phrase "never meant to survive" has to be understood carefully. There is no documented order establishing that Chicago intended to demolish the freight tunnels when service ended in 1959. There is no evidence that every passage was supposed to be removed. The survival was less dramatic than that. The system simply outlived the purpose for which it had been built. Its transportation role ended before its physical existence did. That distinction is not unique to the freight tunnels. Chicago has repeatedly accumulated infrastructure in vertical layers. In the late 1850s, decades before the freight railway existed, street grades were raised in large portions of the city to improve drainage and accommodate sewer construction. Later, Chicago built other multi-level transportation environments. The double-deck Michigan Avenue Bridge opened in 1920. Wacker Drive created another layered streetscape in the following decade. Passenger subways added still another underground system. None of these should be merged into a single hidden city. They were built at different times, for different reasons, with different engineering purposes, but together they reveal something important about the way Chicago developed. New infrastructure did not always erase what came before it. Often, another layer was added. That helps explain how a modern city could continue operating above structures whose original functions had disappeared below. And it brings us back to the old freight railway. After the 1992 flood, its existence could no longer be treated merely as historical background. The city still had to know where the tunnels were. Builders still had to account for them. And modern Chicago procedures continue to recognize a freight tunnel system area when underground construction is reviewed. That may be the quietest piece of evidence in the entire investigation. No flood, no locomotives, no dramatic breach, just a municipal review process acknowledging that this early 20th century system still occupies real space beneath the modern city. The same network that once moved coal and packages now survives primarily as an inherited condition. But that survival has limits the evidence does not allow us to ignore. We cannot say that every original tunnel remains intact. Later, subway work and subsequent construction altered or displaced parts of the network. We cannot say how many original building connections remain physically identifiable today. We cannot assume that every surviving section is accessible. And although portions of the tunnels have been used for utilities and communications, that does not establish that the network was preserved according to one deliberate, comprehensive plan. Even the exact surviving mileage should not be treated as known simply because historical maps show the original system. The physical network has been modified for more than a century, but the larger answer no longer depends on finding every surviving foot of tunnel. The Kinzie Street Breach already demonstrated what mattered. Enough of the railway remained connected for an event at one river crossing to affect buildings across downtown, and that forces us to reinterpret the tiny locomotive and the narrow rails where this investigation began. At first, their scale makes the railway look almost insignificant. The equipment is small, the gauge is narrow, the tunnel is cramped. Nothing about that single passage immediately suggests a system capable of affecting a major modern city decades after its abandonment. But the locomotive was only one moving piece inside a much larger structure. The real machine was the network. It connected freight houses to customers. It connected tunnels to buildings. It carried coal inward and ash outward. It spread beneath the streets until a small underground railway had become part of the physical organization of downtown Chicago. Then the trains disappeared. The network did not. For 33 years after freight service ended, those passages continued to exist beneath a city that was changing above them. Some were altered, some were repurposed, some remained tied to utilities, some retained connections with buildings, and beneath the Chicago River, one damaged section eventually revealed the consequence of that survival. When water entered on April 13th, 1992, the old railway became visible again, not because the trains returned, but because the structure still knew how to connect one place to another. That is what survived beneath Chicago. Not a lost civilization, not a secret duplicate city, not one unified subterranean world containing every tunnel, lower street, subway, sewer, and pedestrian passage beneath the loop. What survived was more specific, and in some ways more remarkable, the physical skeleton of an earlier system for making the city function. A transportation technology became obsolete. Its concrete geography remained. And more than 3 decades after the final freight trains stopped running, Chicago learned that infrastructure does not have to remain useful to remain consequential. Those narrow rails belonged to a railway that ended in 1959. The city built above it kept moving, but beneath the streets, enough of the old network survived to make its history physical again.